Hello, this is Zoltán with ARCHLine, and today is the second part of our two-dimensional design tools essentials training course. If you have missed the last one, be sure to check it out because today we are going to get a bit more advanced. Let's take a look. As always, I'm joined by my colleague, Mr. Illés Pap, our resident architect, who is going to help us to show you the most essential and more advanced two-dimensional design tools. Can you tell us in a couple of words what we discussed last time in the last show?
Well, last time we talked about mostly how to process drawings and how to, use these 2D documentation tools, drafting tools at the beginning and at the end of the process. We also talked about scaling content, using images. We actually covered pretty
Yes.
much about processing images. Today I will work on top of an image initially, but I will try to cover more about the editing tools, how to cut a specific part of a 2D drawing, how to turn them into groups at the end, how to use them as profiles and so on. So we will kind of dig deeper into this world.
That's right, and as always, I urge you to ask your questions on the right-hand side, right next to me. You can ask things connected to the show, and we are going to talk about the answers as well. I'm going to check in now, make sure that you try if this chat bar works on your end. And after that, let's take a look what we have here at hand. So what we are going to discuss first is how to create a bit more complicated two-dimensional tools, two-dimensional forms and shapes, that's what I mean. Because last time what we did is that, as you mentioned, we discussed how to turn this image into something that we can actually use, but today we are going to look at how to get a line drawing out of this, right?
Yeah, well, and processing this drawing, I'm about to show you more advanced 2D drafting tools. I mean, this is just a simple example of how to process a drawing, how to process an image of a door, but this could be used if we, I don't know, process a facade, a 2D drawing of a facade, or anything else. We don't even have to have an image like that. I'm just using it as a background, so it's easier to understand what we will try to achieve by the end of this session.
That's
so,
right.
well, actually, this example is already containing some of the drawings, so I will just simply make a copy of this image. We actually covered this last time, how to scale up an image and how to import an image, so I won't do that again. I just skip that part. So this is, we can accept that this is already a scaled image containing an image of a door scaled to the real world size. So now whenever I measure any point of this image, I should get the real value back. It's around a meter wide and more than 2 meters tall. So if I would like to use this as a 2D drawing for any reason, I need to somehow process this content and turn this anyway pixelated result into something that is, if I just quickly remove this, into something that can be used as a drawing, and however I zoom in, I will always get the perfect drawing.
Yes, because this is, as opposed to what you see on the left, is a vector drawing.
Yes, yes. So even if I design something on my own, I will use most of the tools that I'm using now. Actually, the drafting tools, the tools that you will use for 2D editing, just as we covered it a little bit last time, it's under the drafting. You will find the raster image commands here, text tool here, hatch in, fill up the areas with certain patterns and so on. Now you'll just simply go first with the rectangle tool, because that's kind of a specific tool. If you would like to, quickly just click on 2 corner points of an item, I think this is one of the fastest way. You used this last time to skip, cut out parts of an image, and today I just use it to quickly demonstrate how to draw this contour around. So I could use lines as well.
That's what I was about to ask you.
So that would be a solution as well. Sometimes it is easier to create polylines. If you see that this is actually a polyline. A polyline is actually a series of connected other primitives. It can be a bunch of curves connected together and lines and so on. I will show you how to convert them there and back. But now let's see how I would process something like this. Now again, I could use a line tool here, and then a curve here, another curve here. But again, if I use the polyline tool, and there are quite a lot of options here to even draw multiple lines parallelly together and things like that, I will just simply use the polyline tool. If I use this, I will get a result which will be sometimes open, sometimes a closed shape. Now, the difference between a polyline and a polygon, the polygon is always closing itself. I mean, when you draw something and you just finish it here, it will always close it up. It's kind of similar to using, a slab, for example. It always has a closed contour.
Yes,
you cannot create an open contour for a slab from the top view. So, but if I use the polyline and I just do the same, it just stops there. So if you tend to create something that is an open profile, I will cover that later. You would like to create an open ending profile, an open half circle, half roof profile, or anything like that, you will use perhaps any of these. Or we covered this as well. If you would like to create a revolved item, this is also something that you can. You just create a half profile of glass or something like that, and you just revolve it around, and you will get the result. So now to create this, as you can see, there are many options. Let me just quickly approach this this way. If I know that there is a distance between here, I can also create an offset. I can just click here, and then I can make an offset like this. This actually creates an offset with all of the contours because I used a polygon, which is a closed loop, and then when you use the offset, it will automatically offset all the contours.
Where do we go from here?
Now I just quickly draw one line here, because I also would like to show you later how to unite these together. So there is one line, there is another line here. And I can actually use the polyline here because this is not just one single line. And there are some options here that this automatically appears, this list of commands or keywords automatically appear in the software many times. So now I can just turn to an arc, try to find where this arc turns into another arc, like for example here.
I think that we should be fine.
And then I just set the curve itself. And then I can go with an arc, or I can go with a smooth arc. The difference between the two, if I go smooth and arc, then you can be sure there will be no break point. There will be no hard break between the two, arcs.
Yes.
So I just click here.
It's similar to a spline, isn't it?
Kind of similar. Yeah. So I just finished. I just right click now, and now I have this contour based upon a line, another line, and another actually polyline based on curves. Now I just quickly do the same here. So instead of drawing these little kind of islands one by one, I try to speed up my work. I just would like to create one line here, another one here, another curve here, and then break it apart. This is faster than just making it one by one. Just click here, and then now let me just use the polygon tool so I can show you how to use this in the same situation. I just click here. I can also, of course, if I know the distance, I can type the distance. I just move my mouse here, and then again there is an option here, an arc. It's around here perhaps. There is a smooth arc following up this around perhaps here, and then again it's a smooth arc. So I don't click here because this is disabling the smoothness. So I'm just clicking on arc, and then I just click here. So I think this tracks it pretty much well. I can still change it. I can there are these breakpoints. I can move them around.
You can add additional breakpoints.
This result. So this could be again a point when you say that, well, this is better to track it with a polygon, because then you can handle it as one single unit. Now, to break this apart, I will just simply use an offset. But now if I use this offset here, see, it will offset everything, and I don't want that. In that case, I can break this apart. I can say that, well, let's just go into the local menu and turn this into lines. And this will break this, so edit. And this is already a polyline. Now let me just create this. This is polyline, and I just go here and
Maybe it's explode.
yeah, explode this polyline. Yeah, thank you for that. So I just explode that. So later I will be able to unite this, but now for now I would like to break it apart. And then I use the offset tool, and then I can, again, if I know the distance, I just type the distance. For example, it's 0.2, I type 0.2, and this is around 0.08. And then if I would like to keep the same, I can just keep typing the same values, or I can just, click here and Control copy, Control C, click here, and then just paste, Control V, and just repeat this around. And I wasn't accurate enough to keep the same measures over there, so I just repeat the same thing over with the offset. So you can work either this way or the other way.
Yes.
The same result you will have at the end. Now,
how do you get rid of the lines that you don't need, or you don't do that yet?
Well, yes, we can do that. Now, as we can clearly see, if I just make this a little bit more transparent, let's just turn it to, I don't know, very much transparent. We can see that well, this is not the result that I want. It's close to it, but I need to have closed loops here. Then I use this tool. This is called the between points. Actually, it's intersection points. If I click here and I click there, see there, on this line there is one breakpoint and another breakpoint. There is interconnecting other items. So this is where the software can recognize to remove this part from here and this part from here and this and this. So you can actually go around and clear it up, and then just either break this apart again, because you cannot remove this part. This is still one single line. So again, either you use this or you change the length of the lines. Either way, you get the proper solution. You remove the unnecessary parts, and then you get something like this. Now,
how do you get the inner parts? Because I see on the right that you have an additional set of lines within these panels.
These inner loops. The image is not that much of a good quality, but here we can barely see that it's having an offset. So I can use this offset tool. It's again in the drafting, and it's called this one. And again, it depends. The offset result depends on what I had before. If I have only one line, then it will make an offset with the line only. And if I unite these, I can actually unite these. I can click on this item and tell, okay, let's just turn this, anything I select now, into a polyline. I can select them one by one, tell the software that this and this and this and this is part of the polyline, or I can make it kind of try to recognize it. It's if I go on the select by chain and, it is trying to recognize this whole loop, and then the result is like this.
So
this is much faster. Yeah. So again, let's just do that again around, because I would like to speed up my work and turn this into by just simply recognizing this and this and this and this, and now I have closed loops, and I can go and use the offset tool, and here I can, well, this is.
You have to go with offset tool.
Yeah, sorry, yeah, that was the.
If you click on the, sorry, click on this, you should have an offset tool. Yeah,
that's
here
right,
we go.
Yeah. So what I wanted to use is it's using an offset as you can see on the hint individually one by one, and if you have this same tool in case of a roof or slab, this is the same offset or offset all. And again, you can just type a distance. I will use 0.05.
Yeah, it should be copy and offset.
Yeah, copy and offset.
That's the thing. Usually we work with three-dimensional elements. So when it comes to 2D, then we struggle sometimes because we're not used to do this. But it's a good refresher.
Copy and offset. I just quickly cover this. Now I don't type the values. I just go around and make an offset copy here and here and here.
But that's good because then you don't have to manually offset every single line and then connect them together. Instead, you can do it with this pretty sped up way.
If I create this the other way around, when I make this curve and then this curve and then these lines and then break this apart, it's like, I don't know, like double times the steps. So the approach, how you process the drawing is really important. The same thing you can process very, very effectively if you know the right tools. Or the other way around, you will still get the same result or very similar to that. but it could take longer if you don't know where to, which sort of tool you use. Like for example, I didn't remember that there was this offset a copy. It's much faster.
Yes.
Okay, so
what's the next step? I mean, now we have a line drawing, but how do we get a three-dimensional door model out of it?
So the next step is always depending on what you use this for. If you use this as a group, you turn this into a group. I will show you that later. There is a command for that. If you would like to use it as a profile because you would like to use it as, I don't know, insets or glazing or anything else, then you do the other way around. And if you would like to use this drawing, one part for one specific purpose and the other part for another specific purpose, you can use and break it down. Now, for example, this will be for a simple glazing. There is no inset or no mountains or anything inside. But here, this is a little bit more complex. This is what we call a multiple profile. So a profile and a multiple profile differs in a way when you store it, when you save it in the libraries of the software, it will be one single loop, kind of a counter, or a combination of a lot of counters. Now let's just start with the first. Actually, if you would like to create a new profile, you will find all the possibilities here. A closed profile, a classic closed profile looks like this. You can use it for closed profiles for columns, beams, handrails, many things that are based on sweeps or something like this. Or holes like this. If I would like to turn this into a closed profile, I just start this command. And then now comes the part when I should track what I have created. But instead of clicking on the corner points and making mistakes, I just click here, closed loop, this is what I want. And I just click there, okay, recognize it, use this as a reference point, for example, and then save it. But this should be, let's just, I don't know, profile V01. Okay, this will be the first version of a profile. And okay, now from this point on, I can use this profile for many different things. I can go here and I just find it, what was the V01? There was one profile with this name, and this is it. And when you click and drag, you have options to use it as a column, use it as a beam, and use it as a profile. But what happens if you would like to use this as part of a bigger thing like a door? Well, in that case, you can go to the, for example, in the building door, there is a new door command, and this door wizard gives you a lot of flexible possibilities to build up something based upon a shape and change this inset to something like what I have created.
Oh,
so
yes,
if I just go there and try to find what I've done, it was V01 and this one. Okay, so it changes this, and then I can change how it's adapted to this specific door panel.
I was about to ask you that the measurements come with the profile or only proportions do?
It can go both ways. If I just disable this option, the software will keep this distance around. It's kind of, you can set up what's the height and the width of this inset. You can go back and find what was the original height, but this is how it goes. I think in case of a door, this is much more lifelike when you know what's the offset from the sides that you would like to keep, and then you use those values. Now, to understand these values, you can actually use the original drawing and measure these distances to figure out what should be the value. I actually made a little cheat sheet for myself, but I show you how I measure these values. I just use the dimension, and there is either the length, or you can just use the measure, but in this way you won't have a visual remaining.
It's not going to be written, it just shows you it for a second.
Yeah, so I just use this and measure this distance. Now I'm working in meters, but the measurement is in centimeters, so that's why you see it's 9 centimeters. This is 8 centimeters, and so on. So this really depends. Actually, talking about this, when you would like to use the software with a specific measurement system, the English version comes, actually the international version comes with units and angles in millimeters by default. I just changed this for the purpose of this design. And then you can just close it, and then from that point on, whatever you create and whatever you click on, the software will tell you the length of that specific item in millimeters. So from that point on, this works like that way. So now I just measured these values. I won't measure everything here. I will later load the final version and you will see how I did that. And then I just already saved this here. But then, you know, if I would like to add more and more and more profiles into this door, I would have to, you know, add this one first and then the smaller version of this and then this one and then this one.
Yes, but that's a lot of
tedious. I don't want to do that. I just would like to save this as one single multi profile.
What if the profiles are not connected to each other? In this case, they are not.
Well, yes. In that case, I go to the drafting. There is a new profile, and there's this define multiple profile. I just click here, and then now first thing, again, I need to decide what is the fastest way. Again, I can track this, but in that case, I won't get this hole inside. This is actually this one single part is also made of two other parts. So in that case, it's better to use this point of profile and islands, because in that case, when I click here, the software is trying to recognize the outer loop, and it is trying to find inner loops. These are the islands, which are, you know, kind of floating in this bigger area. So in that case, I just repeat these. I just made it done, and I right click there. When it's orange, I know that I can go and continue progressing the rest. So I again select the following will be again with point of profile and island. I click here. See, it's already orange. I don't have to do anything. Point of profile and island here, and the last one, point of profile and island, and here. See, it's like 6 clicks, and I have this complex shape. And when I hit enter, I'm done. I hit enter, then this complex shape will be used as a profile. You will see later when I save a group that a drawing like this can be saved as a group as well. But for my specific purposes now, I need it as a profile, so I save it as a profile. Let's just name it 02. Okay, this will be version 2. Okay, so now let's put these together into a door and find out how this works. This will be a single door. Let's just go here. Actually, I use these because these are in the proper size. And I go to the details. Now, if you have a door already placed on the drawing and it was originally created with door Bazaar, you have two options. You can either handle it as a classic door, having all the classic settings, but in that case you cannot reach the full depth of the parameters and so on. Or you can go there and find it as an opening property, open up the door Bazaar and further, you know, change its insides. Now, what I would like to have is an inset, so I just turn it on. But instead of this rectangle shape, I go to the libraries, and now first I try to find the 01, this one, which was first created, and I select that. Now it comes here, and now I just use this cheat sheet. I know these values, so I just use 90 here. Let's just refresh that. Okay, that's fine. So that
we can see the result.
There will be another one, 90. There will be this value, which is again 90. And there is this other one, which is 400, like this. So this is what I got here. These are the values that I measured from the original to the drawing. And then, if I would like to add a new inset, I still keep being here, but I'm adding a new inset.
Okay, the panels, are they going to be insets or?
It depends on how I use it. Well, it actually depends on the material that I choose. The original material was an opening glass, but if I select another material like the same pine or anything else, then it will be used as a hard surface. I can change the thickness of it, and again, I should now again change it from rectangle to something else. I don't want to combine these two, but I would like to combine my first profile with the second profile, and then instead of this rectangle, I just go to the libraries and try to find version 2, which I've created, and it's here. Okay, and then now I just turn this again using the values that I originally measured. So it's here on my page, it's 110, 90.
So that means that you have to add as many insets as you actually need, but you don't have to do them separately. you can first save the drawings as multiple profiles merged into one.
Yeah.
And that's the end result.
Yeah. Now the kind of advantage of this thing that is that this is not just a pasted image on a surface. I could use
which, by the way, we have done last time. But
yeah.
this is a better solution
because now it's in 3D. As you can see, you can go closer to this door and it won't reveal itself as a pixelated image. It will give you the details because you literally model those details. So you will have this as a result. And then actually you can even further detail it. You can go and say that actually around this window I would like to have some sort of framing, an inset edge profile, and perhaps I'm using for example this one or the rectangular one or this one, and then it really changes it. It gives more detail into this door or window, whichever we
so
create
that would
now.
be the suggested way of modeling something like
so
that.
you can scale it up, you can change the cross section, you can change even the material, and then you can save the point here is that this door then later can be saved into the libraries. You could click here and you can say, well, okay, I would like to change it into a new library. Sorry, I clicked here. This is for browsing, but this is actually saving it into a library item. So so this is how it's done.
What happens if you have one inset, just one, but that's a bit more complicated, more decorated? How do you do something like that?
Well, for this, I think I load the second stage of this project. It is this. It's actually the finished version, which reveals the target where we go into. But I will show you what's the difference between this door and this door. It's actually based on the same principle. As you can see, this is how I measured these. These are the measurements around. And then again, I'm changing this model to millimeters because that's the default. And then say okay, and then this is how it will work. So see, now there is this door, and there is another one kind of similar to this, but there is a big difference between this door and this door here. And this door has a lot of, you know, carvings and glazing and other sort of things. Now this here is more like a big glazing with little details in it, with, you know, it's perhaps some sort of metal or sometimes wood. Now, this is a profile which is done in a different way. If I go here, you can see that there was this original drawing.
Yes.
For simplification, I just simply skip these parts, but if I would have
Yeah,
more
it
time,
would
I
be just the same thing.
create that. And then I just track that using the same tools, using either the polyline, the line, offsets to create this here, and then, you know, vertical lines, horizontal lines, and then cut the rest that I don't want to see. Now this is, as you can see, it's a bunch of polylines, lines, and arcs. At this point, I cannot use it as part of this door again, because I need to somehow save it as a profile. In this case, I will not save it as a classic closed profile, because the classic closed profile is for that other purpose. It's for insets, it's for you know, carvings and other things. But if I would like to use it like this way, I should use it. It's a specific profile. It's called panel profile. If I click on this one, it is actually having a different way of creating. First, I need to define what's the outer contour of the whole thing, which will create the loop or the inset or whichever reason I use this for. And then the second step or steps will be to define lines or, you know, traces
within the inset.
Yeah, within the inset, and that will be turned into those details that we can see now on the 3D. So let's see how that works. Now first, again, just as I mentioned, I need to follow up the contour. Unfortunately, I cannot use any of these now because these are not helping now to recognize the outer contour. So I just simply go and quickly track the
You just have to track the outer
contour. Yeah. So now I'm done with the external contour. The software is not telling me anything because I already closed the loop, so it understands, okay, that's the hole. Okay, I'm fine. And then let's just define the details. Now I just go with one detail. That's one detail. Enter. Another detail. Enter. Another detail. Well, I just made a mistake here. Enter.
So it doesn't matter what the order is, as long as you start with the outer boundary.
Yeah.
And you
need to start on the outer boundary and finish at any other part of the boundary. So if I go here, click, click, and say, okay, this is an arc. Well, this is kind of a half profile, and then I just start from here and do the other way around. Arc. The whole point is that they must be created in one single step. I mean, these are several corner points, but it's one edge, one another, and one vertical. So this is how you do that. This is the final one. And then when you are finished, you just hit enter, and then the software understands, okay, we are done. Let's just save it as version 3. Into door window, frame profiles. I can actually just select another library panel profile or something like this. Let's just go with that. And then this is how this was used. The second door reveals, if I go to the opening properties, that these are insets. If I disable them, you can see that they are gone.
So there are two insets of the same profile mirrored to each other.
And actually it's mirrored. So there's one and another one, and they are just simply flipped around, mirrored using these settings. So this is how you create that, and then you will have this detail. And again, we could do that using the simple texture, but this is giving you a much more rich content. If you go closer to this door, or if you would like to actually create a drawing of this door, this will have real edges which can be documented.
It's good that you mentioned the drawings, because if you are going to get some kind of documentation, elevation, wall view, etc., then at the end, then there's going to be the exact model that you created with all the details.
Yes,
perfect.
That's right.
Maybe you can show us another example where you use this on a furniture front. Furniture front is a tool that we have already covered before. There's a separate webinar on that, where we actually mentioned that the furniture front is a very versatile tool. There's a lot of things you can do with it, and this is going to be another example, one of those things where you can use these elements to turn the furniture fronts into something more spectacular.
Yes, that's right. Actually, I have already created this as an example. Here it's on the right hand side. And it's actually, let's just repeat how this was done, because for this specific purpose, I still have to use the define panel profile for doors and windows. It's not specified here that the door is a building door or a front of a furniture. It works for both of them. I just use this again, and so the first step, define a counter. Second, define the mountains or the internal parts. So okay, let's just go around and do that. I just click here, 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 and there is a smooth arc, I'm sure, here. Well, it's actually not smooth with this one, so let's just undo that and say this is non-smooth. It's actually just a simple arc, and it's going around here. Now, with the previous one, it's a smooth arc, and then here again, it's still smooth, but here it's non-smooth.
Yeah, so if you have a hard turn, you don't have to go with smooth.
Yeah, okay. So I have this counter, this is the outer counter, and then the internal counter is just one, enter, another one, enter, and the third one, enter, and then save it.
Again, you save it, name it.
Let's just make it 04. And okay, and this is how the profile used for this specific furniture was used. And in this case, if I would like to reveal how this was done, and go into the details of this door, I just alt click. I just keep holding the alt key on the keyboard, alt click on the door, and it reveals that this is actually a custom object. This was never saved. So I go to the edit. Let's figure out how this was done. And is there any sort of inset? Yeah, yes, there is an inset. That this inset is actually the hole itself. And is there any glazing? Yeah, there is a glazing. This is for the glazing. And then actually there is nothing else. There is no carving. There is we call this an additional profile. This is making these horizontal and vertical bars here, and this way you can create that. If I erase it, you can see how this would look if I do not create this additional profile. So this is how it was done. You can save it at the end, and then you can use it in other projects. I think it's kind of useful to know that you can at any time go back and edit these. These are still flexible and available for you to edit, and you can just create as many versions of these profiles as you wish, because sometimes you use the same profiles just with different, basic settings, basic sizes, or different variations of the vertical and horizontal bars. You can do that and you can save those.
In the beginning, you mentioned that open profiles are different.
Yeah.
Maybe can you show us an example of how an open profile can be used? Because you said that with closed profiles, you can use them for pillars, sweeps, anything. But how are open profiles special?
Well, an open profile, a classic open profile, can be demonstrated using a gazebo roof, because, or we could use another example, like a revolved object, like a glass or a mug or something.
So when you're using the Revolve 360, the solids of evolution,
that is also an open profile. An open profile is classically demonstrated here. I have a photograph of this gazebo roof with the underparts, and then there was a frontal view with all the measurements, so I actually scaled it up, and then this is how I got this result. Now, if I would like to track this and save this as an open profile, I can use the define open profile. For this specific reason for which I will use it now, for the half profile of a roof, I don't even have to save it. So let's just start with this first. I go to the building and there is the roof, and then here you can find is the auto roofs. So these are very useful. You can even create a classic gazebo without this specific shape. But if you would like to create a roof with a profile, this is how you will go. You will just click on this one, and the first thing you have to define is the half profile of that thing that you would like to track. And
so you just have to sketch half of it, right?
Yeah, you don't have to sketch the whole thing around, because the whole point behind this is that the half profile that you define will be used as kind of roof plane on each of the edges wherever you design this on your drawing. So you just click here and you say, well, again, let's just go with the smooth arc. We already know how to use that. I just click here. This is an arc here, and then a smooth arc around here, and I'm happy with this, so I just go with there and then enter. Now, there is one last thing that you should not forget to do, and that is, now we are in a context of a roof, and a roof is always placed with a specific alignment, but this is the roof plane. The roof plane is always aligned with a specific point to the so-called reference line.
Where it meets the walls, right?
Yeah. So this is where you decide where that reference line should be. If you click here, there will be no overhang. If you click here, there will be this overhang. So this is the point which will be aligned on top of the profile. So this is how it looks like. There you will always see this elongated left-hand side appearing at the left-hand side.
What does that mean?
This is actually, now I believe this is 45-degree angle, so this is the default setting of a roof now. There is a default setting for the roofs. Whenever you create a roof, an automatic roof, this is the angle how the roof will be handled. And why is that there? If you defined a half section of anything and you design something wider than this, without this, the software wouldn't understand how to fill up that gap.
Oh, so there could be a gap.
There would be a gap.
I see.
But we don't use it as something that we would like to, make it an open thing. This is a roof, so this should be fully covered. So this is how the software makes you understand that this is how the rest will be filled up. So let's just go with this one. I'm happy with this one, and now I'm at the point when I need to define the shape of the top view of this roof. Let's just go with this polygon. And this polygon will be created around here, and here, and here, and here. I do not create a perfect hexagon now, but it's still very detailed and very, very much similar to what I wanted to create. So this is what
so again, you first sketch the half of the section profile.
Yeah.
And then you outline then you add the reference point where it's going to be fitted to the walls.
Yes.
And then you add the track the walls onto which the roof should fit.
Yes. And this is how you can create something like this. Of course, the rest was created by using walls, slabs.
Yes, but this gives you
columns,
an idea.
But at the top, this is how this gazebo was created. Now, well, actually, sometimes when you track a drawing like this, it is helpful to understand how you can create, again, pre-shape what you will achieve. Like there you would like to create something with a radius of 1.5 meter. Again, there is a tool for that. Of course it's the circle. The circle comes with many different options, but mostly I use this by center point and by 3 points. But depending on what I would like to create in other situations, I can use this. Let's just use this. If I would like to reproduce what was created here, I just click here and then I type the radius. I can check whether the radius was fine. If it's not, I can change it. And then here in the polyline, you can actually create a polygon either circumscribed or inscribed in a circle.
Mm-hmm.
Now what I need, the maximum edge, the most distant edge of this polygon should be at the 1.5 meter radius. I would like to create something that is inscribed. So in this case I go with this one. What should be the number of polygons? That's the sides of this thing. It should be 6. Okay, and then I start with the center and I do that. So this is how you can do that. For this reason I don't have to pre-visualize a circle, because when you make the most distant point you can actually type that, but this way I could visualize it much better, I believe.
Perfect. In the beginning you mentioned something about groups and the difference between the profiles and groups. Maybe you can tell us more what groups really are and how we can create and edit them.
Well, if I would like to create a group, like my custom title box, mm-hmm. or my custom north sign, or any sort of custom electric symbol or something like that, all I need to do is to either import it either as a DWG file or something like that and process that as I did it, as a group, or draw the parts by myself and define that as a group. Why is a group specific instead of just creating a bunch of lines? The point here is that if I would like to make this into a symbol, and then I just would like to make copies of this symbol, I would like to just simply rotate it, or I just would like to move it around. If they're not grouped, then I always have to take care not forgetting anything from the selection, or either I need to do that, but in a complex situation it's not possible to accidentally select something that I don't want to. It will be very, very difficult. So to avoid this, you can create a group. You have two options. You can either create local group. That means this is finished. It's done. It's from this point on, when I click on it, it's a group and I can move it around. I can break this group apart. I can say that, okay, explode this to the original state, and then from that point on I can, again, do whatever I want. This is kind of the temporary grouping, when you don't want to save it as a library item and make it readily available for other drawings. But if you would like to use it as a future symbol, then instead of this, you should select this and go into the group and say, well, this should be a group in a library.
I see.
Let's say this is a symbol of something. Let's say this is, I don't know, for a specific purpose, where there is a letter inside. I just make it a little bit more complex. Say there is something like this here. Perhaps it's for gas pipes or some sort of symbol. I just select it.
Or some kind of special equipment within a house.
Special equipment. So I just select it and I go here and I say, okay, create a group in library. Now there is an extra step that I need to define, and those are what I'm defining now are the reference point. Now there is an important step here. The first reference point will be the first offered. Mm-hmm. Now when you define more than one reference point, then you can cycle through these later when you place it.
Oh, so when you're placing something and you keep on hitting the F5 key to toggle between the reference points, this is where you can actually edit them.
So if I know that this specific symbol is most convenient to place by its center point, then this is where I click first. And then if I know that this should be the second, and this the third, and the fourth, and the fifth, and so on, I can define as many as I want. And then when I'm done, I hit enter. This is where the software allows you to save it and name it, and then we'll offer this as a symbol in the library. Let's just save it as symbol T. And this goes to the, let's say it's electronics or something like that. and its accessories, fine. I just organize it, and then when I go to the groups and I try to find it here, I will find it in the electronics and accessories, and then now in between all those rests, I can just click, and the first offered reference point is the center point. Now, if you would like to switch between the reference point, you have two options. When you place a symbol like this, you can either double click here. Double click now. Then you can pick 1, 2, 3, or 4 or 5. Wherever you click, it will be the default. Or you just click and drag. It remembers the last one, so let me just turn it back to the default. It was the center. Okay, so let's just click and drag, and then you can cycle through, just as you mentioned, with the F5. Number 2, number 3, number 4, number 5, and again back to
goes back to the
1.
beginning.
Yeah,
Perfect.
so this is how you do something like that. Remember that whatever you create, its default size will be the original size how you create it. So that's why when I refer to the groups as title boxes, like for example, when you would like to define or create your own title box, design it in the real world size, like the paper size. If you know that you have a title box for an A4 paper, design it in that size, and then you don't have to continuously reshape and resize it for different purposes.
Yeah, so draw everything in one-to-one.
Yeah.
Just like we did with the walls and every
That's right,
doors and the roof panels, we always scale in. We always work in one-to-one. And that's what we actually wanted to discuss during this second part. Again, if you missed the initial course that we had last week, you can find it on the website. And that's combined with this, you can use these tools to make amazing three-dimensional models and improve your two-dimensional drawing skills as well. Now, let's talk about what happens next. Next week, it's going to be all about upholstered furniture. Now, you might have said that we already did a couple of webinars on furniture pieces, but this one is going to be special because upholstered furniture have a lot of special features, including how the fabric looks like, wrinkles and things like that. So there's a lot
more organic than the classic furniture. Yeah.
Again, this could be used to model other things as well, but one scenario which we found them to be very useful is when you design this kind of armchairs, sofas, and
headrests. And
that's right. So make sure you are going to be there. Thank you for your attention, and we'll see you next Wednesday at the same time. Thank you.
See you. Goodbye.